This is Echo, a huge, shiny balloon NASA, launched into space in the 1960s. It had no electronics, no fancy tech, just a giant metal balloon that bounced radio signals around the world using its reflective surface. And surprisingly, it worked really well. Right after launch, President Eisenhower sent a voice message all the way from California to New Jersey using Echo. Back then, global communication was only possible through an expensive and complex network of undersea cables. So the idea of bouncing signals off a satellite? Totally mind-blowing at the time, proving satellite communication could work. Before Echo, not everyone believed this would even be possible. Some scientists thought the Earth's ionosphere would block radio signals from reaching space. So NASA decided to run a test using the moon as a giant reflector. They successfully bounced a voice signal from New Jersey to California using just the moon. This proved radio waves could pass through the atmosphere and be reflected back. Just like how light bounces off a mirror, radio waves can bounce off large objects too. The bigger and more reflective the object, the better the signal. Building Echo 1. To work properly, Echo had to be huge. It was made from ultra-thin mylar plastic, about 1/10, the thickness of a human hair. Over 100 pieces were cut, coated in shiny aluminum, and glued into a giant sphere. On Earth, Echo would need 18 tons of air to stay inflated. But in space, with no air pressure pushing on it, it only needed a few kilograms. In 1958, NASA tested an inflated Echo on Earth. It was the biggest thing ever launched into space at the time. But they couldn't launch it fully inflated, it had to be folded up and inflated in orbit. How did Echo inflate in space? Echo didn't carry tanks of air. Instead, it had small canisters of benzoic acid, a powder that turns into gas when heated by sunlight. As soon as it reached orbit, the sun's heat expanded the gas, and in just seconds, the balloon inflated. But space is full of tiny debris and micrometeorites. What if Echo got a hole? NASA planned for this. Echo 1 had extra benzoic acid to reinflate if needed. Later, Echo 2 had a better solution. It had aluminum layers that made the balloon rigid. Even if it got hit, it would hold its shape. Echo was bright, and that was on purpose. These giant shiny balloons were super visible, even brighter than the North Star for almost a decade. That was actually helpful. Ground stations had to track the balloon across the sky to send and receive signals, and spotting it visually made that easier. Later, NASA added a tracking beacon to help locate Echo even during the day. Most of the communication happened between special ground stations in California and New Jersey, but because Echo orbited over the whole planet, anyone with the right equipment could use it, even the Soviet Union, who called it the friendly Sputnik. More than just communication. Echo wasn't just for bouncing messages. It also helped us measure Earth more accurately. Back then, measurements between cities or continents could be off by over 100 kilometers. By using Echo as a reference point in the sky and measuring how long signals took to reach it, scientists could triangulate exact distances, improving accuracy by 10 times. What NASA learned from Echo? NASA also learned how satellites behave in space over time. Echo's orbit slowly changed, not because of air drag, but because of solar wind from the sun pushing on its huge surface. Echo taught NASA more than anyone expected. Its signal receiver later helped discover the Big Bang. The materials developed for Echo are still used in spacecraft today. Although satellites like Echo didn't become the standard, it proved that space communication was possible and set the stage for everything that came after.